Is Tina Vanzel, and I currently serve as the president for Wisconsin Tribal Conservation Advisory Council. Often we refer to it as WCAC. I would like to welcome everyone today for the Emerald Ash Borer web series. WCAC was established in 2001, and we are a 501c3 organization that provides a forum for 11 Native American tribes in Wisconsin to identify and solve natural resource issues on tribal lands. We have become the voice when speaking to state and federal agencies to address conservation issues. We seek grant funding to address common conservation concerns amongst the 11 Wisconsin tribes, as well as promoting outreach and education, and that is how we have come here today to provide this web series. I would like to thank our WCAC Deputy Director / Tribal Pest Survey Specialist, Lacey Hillcaster, and our Stockbridge-Muncie Representative Paul Cole for all their hard work and planning to make this training available. They have gathered some excellent speakers for this web series, and I hope it is all beneficial to you. I would like to thank the speakers today. And with that, I'm going to turn the meeting over to Paul.
Well, thanks a lot, Tina. We're so glad you could come along and open these up for us. And I'd like to, welcome everybody to the 2021 Emerald Ash Borer web series hosted by Wisconsin Tribal Conservation Advisory Council. So we're really excited to have so many people interested in this topic. I think we're well over 100 participants right now. And I guess I'd like to start by thanking everybody that helped put this all together. There was a huge team over the last, I don't know, probably year or so that we've been working on this from all over the country. And especially I want to thank Lacey for really taking the lead on so much of this, all the IT stuff, presenter contacts, agendas, and just absolutely indispensable in that area. So I guess we'll start off with why did we decide to do this web series? I mean, EAB was detected almost 20 years ago, but for much of rural Wisconsin, we're still on the forefront of it. It's not in a lot of our areas yet. So there's a lot of people that are still very interested in how to prepare and get ready for this inevitable infestation. So on top of it, there's been a hot topic lately. Deregulation is pending in the next couple of weeks, which we will talk about one of these series. And this whole webinar series is kind of to give a broad overview of EAB, the ecology, entomology, regulations, planning techniques, management, and definitely focus on a lot of the cultural issues that we have with EAB. And hopefully people can better grasp the importance of this issue and gather some tools to prepare for the insect and hopefully to help mitigate some of the damages associated with the imminent infestation. So as a lot of you see it on the agendas, each week of the 6 weeks, we'll have a general topic. Like this week is EAB 101, preparedness, silviculture, week 4, and you guys can see the agenda. So each week, though, we're planning on having like 60 to 90 minutes of presentations from the leading experts around the country, and then end each session with a question and answers period, which will have all the presenters available, and we'll ask them questions that anybody has as they come up. So as the presentations move along, if anybody has any questions, please type them into the Q&A tab at the bottom of your screen. There's also a chat feature. Please use that for things like technical issues or something if you want to get a hold of one of the hosts. As far as the rest, the agenda, speaker bio, recordings of each of these presentations, and some supplemental material will all be posted on the wcac.org site. Also, recordings will be on the WCAC Facebook page and also the YouTube channel. Kick it off, we have the rock stars of EAB lined up to take us on this journey. So I guess we should get started. I guess first, I will be your host for the 6 weeks, hopefully, as long as nothing else happens. I am Paul Cole. I am the tribal forester for the Stockbridge-Muncie Reservation. I got my bachelor's degree in forest ecosystem restoration and management from the University of Stevens Point and a master's in forest ecology from Michigan Tech. I worked for the U.S. Forest Service for 8 years at the J.W. Toomey Nursery. And after that, I landed at Stockbridge for the past 8 years. We are a pretty small operation. There's me as the forester and 3 other employees that help manage here. And we do pretty much everything from sale prep, plan writing, administration, work with invasive species, wetland restorations, prairie restorations, wild and fire, wildlife, you name it, we kind of do all of it. So I guess the Stockbridge-Muncie Reservation, if you guys aren't familiar, is about 25,000 acres in central eastern Wisconsin. About 16,500 are forested, and another 6,700 are wetlands. We have almost 2,000 acres of hardwood swamps, which are dominated by black ash. So there's a large component of black ash on this reservation. And then of the upland forests, about 10,000 acres of that is northern hardwoods, with a heavy 10 to 15% white ash component. So we're looking at 10 to 15 million board feet of white ash in this forest. So emerald ash borer is a big concern for us here. We have a lot of ash trees. Currently, we are doing some pre-salvaging of white ash as we go through. Hopefully, we can get through a lot of our ash before the EAB gets here. It's not far away, so we are seeing it. We'll see it soon. We have been underplanting some of our white ash, our black ash swamps in preparation, trying to get some seed bank and sapling layer going. And we've looked at some studies with looking at the hydrologic changes and looking at risk assessments and things for invasive species. So Stockbridge-Muncie people are, they're worried about the habitat loss. They're worried about wildlife, cultural significance of things like brook trout and the warming of the water from the loss of canopy. The timber value is a big deal because we have a very active forest management regime, and the money generated from such funds, it all goes to land acquisition to buy back a lot of the reservation that's been lost over the years. We do have some basket makers that are looking to preserve that resource, and fuel wood. There's a lot of families that burn firewood, so ash is a very important species here, as it is across a lot of the reservations in Wisconsin and Midwest, and probably all of the eastern states. So I guess while I've been at Stockbridge, I've also had the opportunity to work with the Wisconsin Tribal Conservation Advisory Council, and have been the chair of the Forestry Committee since 2016 when we developed that committee. And I guess, so why is WITCAC involved in this web series? Through the Forestry Committee, we try to provide a forum to promote sound forest management across all tribal lands. And as we have usually quarterly meetings, it's very important that each of those meetings has an educational component to those meetings. And well, you're in one of those educational experiences right now. So why we looked at EAB as one of our big topics, which obviously now has ballooned into a pretty big endeavor. There's a lot of tribal need out there for information like this. We, as the 11 tribes in the Midwest, we don't always have, resources for a dedicated forester, or, we've got a lot of natural resource professionals from the whole gambit. So, there's a lot of people that may be managing a black ash swamp that come from a fisheries background or something like that, and just having these conversation and educational experiences to bring all those professionals up to speed on these kinds of topics in forestry, we find is very important. Also with WCAC, obviously it's the 11 tribes. We've touched on a few of the cultural significances of ash, but I mean, yeah, baskets, fuel wood, wildlife potential, sustenance with game species, the timber resource, revenue for some tribes, and also just the spiritual significance of these species on the landscape. So we found that WCAC was a really good fit for a topic like this. And I guess finally, the bug's coming and it's going to be here soon. Oneida is on the eastern part of the state is dealing with the bug pretty much right now. It's detected a couple of years ago, but the majority of the Wisconsin tribes are still just getting ready and in the planning stages and the preparation stages. So it's kind of time sensitive to get this out and get it back on the forefront for everybody. So that's kind of what I've got. I guess hopefully we're ready to move on to Dr. Tony D'Amato. He's our first rock star to talk on these topics. So Tony is a professor of silviculture and applied forest ecology and the director of forest program, the forestry program at the University of Vermont. Tony received his bachelor's in forest ecosystem science from the University of Maine, his master's in forest science from Oregon State, and his doctorate in forest resources from the University of Massachusetts. He was a faculty member for 7 years at the University of Minnesota and a Willard Fellow at Harvard University's Harvard Forest before joining the University of Vermont in 2015. Tony's research focuses on long-term forest dynamics, disturbance effects on ecosystem structure and function, and silviculture strategies, conferring adaptation potential within the context of global warming, which includes introduced insects and disease. So please, let's all welcome Tony D'Amato.
Thanks, Paul. And you kept referring to rock stars. It's certainly not me. I'm clearly the opening act for the real rock stars coming after me today. But I do appreciate the invitation and the opportunity to be part of this series, and certainly talking about a topic and ecosystems that I care quite a bit about. And so, what my hope for today is just to really provide a quick overview. And I know for some of you this will be review, but just to give folks some appreciation for why we should care about EAB, particularly in the context of the potential impacts it's going to have on the critical ecological and cultural resource in the Great Lakes region, namely black ash forests. But before I get into kind of talking about this work, I really want to acknowledge that I'm certainly the one that's presenting today, but much of what I'll be showing really has been a tremendous collaborative effort, largely led in collaboration with Brian Palick, Northern Research Station, but with many other folks across the Great Lakes region, as well as in the Northeast, coming together and trying to find ways to both understand what the impacts are going to be of emerald ash borer, but also, as the series will certainly get into in subsequent weeks, trying to understand what are some options that we have that can hopefully sustain the values and the functions of these key areas as the insect spreads more widely across the landscape. So what I plan to do again in this brief session here is really getting to the title here, why should we care about emerald ash borer? And my focus really will be on why should we care within the context of what we might lose, and really getting into some of the functions that black ash plays on our landscape, primarily from an ecological lens, and really sharing just what we've been able to sort out over the past few years in terms of the variety that we see in the context that black ash exists, and some of the functions that it plays in those settings as it relates to both hydrologic function, certainly habitat values, as Paul mentioned, both in terms of amphibians, invertebrates, and mammal species, as well as just trying to understand, why our area is dominated by ash and what is kind of the role of that species. And so I won't be focusing much more on species like white ash and green ash, but certainly we'll bring up those where relevant in this presentation. And so the reason why black ash is the focus is that as many of you appreciate, when we think about emerald ash borer and the species that it impacts, and certainly Deb will talk more about this in a little bit, black ash is definitely the most vulnerable of our North American ash species. And when we look at how black ash exists across the landscape, borrowing this map from Nate Siegert, if we look at the Upper Lake States region, really the highest concentration of black ash in the US is found in this region. And so from a component of our landscape, it's certainly quite common. And what's more challenging as we think about emerald ash borer is that when we get into these areas like this black ash swamp pictured here, not only is ash common, but in these local scales, it often is the only species or a dominant species over 10 to 40 acres, depending on the context that we're in. And so not only do we have a lot of black ash on the landscape, we also have forests that are almost purely dominated by that species. And so certainly creating some concern in terms of the impact. But most of what I'll talk about today are ecological impacts, but as Paul alluded to, and certainly many of you appreciate, and certainly we covered in other aspects of this webinar series, far superseding the ecological impacts or the cultural impacts that emerald ash borer will have, particularly by impacting black ash. And this picture here in the lower right-hand corner is a series of baskets really that illustrates the biocultural range of importance of that species. And so here we have potato baskets that are made by Richard Syliboy, who's an Aristocrat Band of Micmac member. We have jewelry baskets made here by Sheila Ransom, who is an Akwesasne Mohawk member. And then moving to the Lake States, we have decorative baskets here that are made by Kelly Church, who's a member of the Grand Traverse Band in Michigan. And so really speaking to throughout the range of that species, both an important part of cultural lifeways, but also the land that I currently sit on here in Vermont, which is the ancestral land of the Abenaki people. Those familiar with the Wabanaki, the creation story actually starts with Glooskap, who is the god of nature, shooting an arrow into a black ash tree. And from that black ash tree, the Abenaki people were born. And so when we think about ecological impacts, again, those are far below cultural impact and what it means for this species to be threatened on the landscape. And so important to acknowledge that. But what I will do really is dig into kind of what we've been learning about the ecology of these forests over the past 10 years or so, trying to understand both, what does ash do in the landscape? It's a species that at least Western science and certainly traditional forest products industries didn't focus a lot on because these are wet areas, often low value from a timber product standpoint. And so really over the past decade or so has been an opportunity to really learn more about these forests and understand how they're threatened and what we might be losing from the landscape. So as I mentioned before, when we look in these areas and try to understand the role that black ash plays, unfortunately, the title of my talk, Why You Should Be Concerned, the more you look at black ash forests, as many of you appreciate, the more concerned you get, because what you find in those areas is that black ash strongly dominates the composition of those forests. And so what we're looking at here is just, these are from 6 old growth forests in Minnesota, just a proportion of the overstory trees that are black ash relative to other species. And so just looking at these natural stands, very clearly black ash is over 70% of the species on the site. And some of the other species that we see in low abundance, certainly cedar, red maple that we might find in lowlands, they're out there, but when you look at them, they're not really dominating much of the area. And so there's certainly some concern over what might happen. Also, these are from Minnesota. So as you move into Wisconsin, as well as Michigan, and certainly to where I work now in the Northeast, hemlock as well as red maple become a bit more important in these forests. But again, black ash remains really the dominant signature in these systems. And so what we've been doing over the past several years, and this is work that Brian Palick has been doing, is looking regionally at these black ash wetlands and trying to understand how common is black ash, and then also if black ash were to be impacted by emerald ash borer, what's out there for non-ash species that possibly could take its place and maybe sustain some of those functions. And so this is some work that's about to come out in a publication just showing the abundance of ash versus non-ash tree species in a couple of different habitat types, so wet and very wet, so both lowlands. And these are over 35 sites in northeastern Minnesota and in central Minnesota. But we generally see both the overstory and the midstory, dominated by ash, primarily black ash. And then when we look in the understory layers, so beneath that canopy, what we find is that there's kind of a mix of ash and non-ash species, but a lot of what dominates the understory of these forests, as many of you appreciate, are species like tag alder, sometimes willow, that actually are never going to become overstory trees. And so if we were to lose ash from that canopy, really some of the concern, and something I'll talk about as we go through this, is that we lose this forest from being a forested wetland to possibly kind of a shrub wetland or even a marsh-like condition. So when we look at the landscape and try to sort out where black ash fits into things, it's important to kind of evaluate how it relates to other lowland forest types, because these are wet areas. And so it's worth understanding these black ash swamps and how they fit into kind of the range of forested conditions that you might have on the landscapes that you work in and walk around in. And so what this figure on the right is just showing is kind of a range of forests ranging from what we might view as well-drained sugar maple forests, so places where your feet might not get wet unless you're barefoot out there in April, down to kind of a sedge-dominated marsh, so really, really wet conditions. And so as we increase in the amount of water logging, so kind of the duration of flooding, we go from very mesic systems to black ash forest, ultimately what we might consider kind of open wetlands. And so what's important to point out is that even though a lot of us look at black ash forest and say that's a stagnant wetland, really low productivity, black ash actually requires quite a bit of nutrients. And when we're looking at a black ash forest, even though it might look like the water's just sitting there, these are areas actually where water is slowly moving through them. And that water movement is actually providing enrichment of nutrients and allowing ash to dominate those sites. And so when we start looking at kind of where ash dominates the landscape, it very rarely are areas where we have stagnant standing water. It's these places where we have some movement through the landscape. So putting that in the context of all the forests that we have in the Lake States region, what I've done here in this diagram that comes from the Minnesota DNR is just show kind of where black ash forests exist relative to other common forest systems based on both how wet they are and the nutrient status. And this is from Minnesota, but for those from Wisconsin and Michigan that like to use COTAR's classification system, I've put those up here too for those habitat types. And so what we have here are things like red pine forests, northern hardwood forests that we would consider uplands, so dry systems, and then above this line are wet forests. And so we have things like peatlands all the way over to floodplain forests. And where black ash forests really sit is, again, they're actually quite nutrient rich. You notice they're kind of halfway through the nutrient rich status portion here. And are places where they're wet, but there's still water movement going through them. And so when we factor in kind of how these forests might change in the future, just to assume that, well, we'll just plant some black spruce out there or plant some of these species that do well in terms of what's happening with these other wetlands are quite critical. And so someone asked wet versus very wet. In Minnesota, that would be a WFN 64 would be a very wet ash community versus a WFN 55, which would be wet. And so somewhere in between, again, I'm going to not to bore people with acronyms, FNAVARON in Wisconsin, and the FNARL habitat type. So somewhere in between them, both places you want to be wearing boots. They're both wet. The other thing to notice is this actually a picture from a black ash system in the bottom right-hand corner, and you can see actually there's water movement going through that in the spring. And so places where they're staying fairly well aerated and so forth. All right. So not all black ash forests are the same, and it's important to recognize that where they exist, either in your landscape or in other parts of the region, have distinct differences in terms of the hydrology and how black ash influences that. And so one of the things that we've been looking at are trying to understand those different, what we call hydrogeomorphic settings, kind of how does black ash sit in the landscape relative to the level of moisture dynamics that happen in those forests. So there's three kind of main classes we think of where black ash exists. Very common situation in Minnesota and in areas with large glacial lake basins are these large lowland complexes, so very little topography. Many of you that live in areas where there's morainal type landscapes, so kind of pocketed, these pocket wetlands or swales, these depressions that might have small areas of black ash. And then also a very common feature are these transitional black ash forests that go from kind of maybe a lake basin or another wetland and transition into the uplands. And what we're looking at here is just a water table over time in the given growing season in these different settings. And so the key pattern to recognize is that if this dotted line here is above the ground table, early in the season, we see water above the ground table. And then as the ash starts to leaf out, we see that water table go down below the surface, less pronounced in these swales, but still that same dynamic. And with the exception of 2016, which many of you remember was a ridiculously wet year, generally, once ash starts to leaf out and use water, it's kind of pulling that water table below ground and really influencing kind of what we see out there in the landscape. So just to hone in on that a bit further in terms of why you should be concerned, when you start looking at, again, this is the height of the groundwater table. So any values above 0, you're seeing water. So you're definitely wearing boots. Early in the growing season, right, things haven't leafed out yet. We still see water above the surface, but as things start to leaf out and then reach peak leaf area, so the leaves really start coming out in these trees, we see that water table drawn down. And even when we get pretty large rainfall events, the ash using that water as well as other species kind of keeps that hydrologic table fairly stable. And so really providing that key service and keeping these areas, they're still wet, but certainly not flooded. So when we look at these black ash forests, and as I mentioned, and think about their dominance on the landscape and how common black ash is at local scales, one of the things that work that John Allmendinger in Minnesota has shown is that if we look historically back in the historic record, hundreds of years in the past, and evaluate the dominance of black ash in different areas of the landscape, it's pretty clear that black ash actually has been very effective at establishing on these sites and maintaining its dominance over time. And so what we're looking at here is just relative abundance of black ash over stand development. And we can see it's always above 50% or so. And many other species will coexist with black ash, but you notice that at no point in time does black ash drop below 50% of the dominance in these sites. And what this speaks to, and something I'm going to talk about in a moment, is that black ash is really well adapted once established on these sites to kind of reproduce and do well in these areas based on the hydrologic regime and the nutrient regimes. And what allows it to do that is that reproductively, it's a species that has several ways to deal with the hydrologic regime, that flooding regime that exists in these local places. And so one adaptation that black ash has, as does white ash and green ash, is that it has the ability for its seeds to remain dormant. In the case of black ash, up to 8 years. In white ash, a little bit less than that. And so what that allows it to do is those seeds can stay in the system and basically be dormant during periods where it might be too wet to germinate, and basically allow it to capture those opportunities that are ideal for its germination. Likewise, it's a species that's able to sprout both from its stem but also from its roots. And so what folks have found is that in riparian settings, oftentimes when there's a lot more flooding happening, it'll start sprouting because it's a much more reliable way to reproduce. And then finally, those that know a little bit about what trees need early on to survive, a flooded root system is not a good situation for a tree because it can't get oxygen down to those roots. And so what young black ash have, as well as green ash, are what we call lenticels, these openings on the stem that allow it to actually take in oxygen and bring those down to its root system. And so even though its roots are flooded, it's able to still get the oxygen it needs to dominate the site. And so once established, it's quite well adapted. And so as we think about why we should be concerned, sadly, this is a species that is very well adapted to the places where it exists. And so there's not many others that have these physiological adaptations. So when we look at the history of some of these forests, what we're looking at here is just a graph of the number of trees that began their lives historically, and these are old growth stands. And so black bars are black ash forests. So if we look at the history of some of these areas and when black ashes began their lives, and this is based on us taking tree ring samples from these forests, what we generally see is that black ash has been able to establish for long periods of time and kind of this uneven age structure. And that when we evaluate black ash, Fractionis nigra, relative to other species on the site, there are no other tree species that we find in these areas that can live as long as black ash. Actually, the oldest black ash we've found is over 314 years old. And so tremendous longevity in these forests. So as again, we evaluate what's going to happen if we lose ash from these areas, one of our concerns is there really aren't other species that have that potential for longevity on the site. So when we think about black ash and its role in the landscape, a term that we often use is that this is a foundation species. And what we mean by that is when we go into these black ash forests and we look at the functions, like I've just been showing you in terms of the hydrology and how black ash influences that, one of the things you quickly start observing is that black ash has a very important control over a lot of the different things, both food webs, habitat use by organisms, as well as some of these hydrologic functions. And so this foundational role is something that we really should be concerned about losing and trying to find ways to maintain. And so one of the things we've been doing is documenting alien activity. Now, sorry, this is an experimental area, not an alien landing, where on the Chippewa National Forest, where we've been manipulating different conditions to try to evaluate what will happen to the forest when ash either is killed by emerald ash borer or potentially somebody preemptively cuts ash in response to that impact. And so I'm going to be showing you some results and some outcomes that are just, why you should be concerned based on some of these studies. And so what we've been doing is comparing intact ash stands to areas that have been harvested in response to EAB, as well as areas that have been harvested with uneven age management, kind of more partial harvesting regimes, and then finally places where we've actually been girdling ash to kind of simulate the impacts of emerald ash borer on that landscape. And so what you'll be seeing as I go through the remainder are kind of what we've observed and why we should be concerned in terms of what happens out there. And so I mentioned the hydrologic influence of ash on the landscape. And so what we've noticed in areas that have either been cut preemptively in anticipation of emerald ash borer or have been girdled, again, to emulate emerald ash borer, is that if we go from early in the growing season into later in the growing season, these two lines represent either areas that were clear cut, so all the ash were cut, or were girdled, so all the ash were killed. And in both those cases, what we see following ash mortality is an increase in the duration of flooding, up to sometimes over 3 weeks in time, relative to intact ash forests, as well as those that are being treated with uneven age management. So really highlighting kind of the influence that ash has on the hydrology, and then why we should be concerned about losing that influence. What we've also really grown to appreciate, and this also relates to white ash and green ash, all three of those species have very high quality leaf litter. And so it's very desirable by microorganisms, and certainly creates in the uplands under white ash very high quality soil. But in aquatic environments, so in aquatic food webs, ash leaf litter is actually a very high quality food source. And so there's been work that have shown tadpoles, as well as other organisms, are much more productive when they're eating either the litter directly or algae that grows in that litter. And so some work that we did was looking at caddisflies, and I didn't do this because it's pretty cruel stuff, feeding caddisflies different types of litter. So we have black ash, speckled alder, swamp white oak, as well as other species like lake sedge, American elm, and balsam poplar. And what we found was consistently those caddisflies that were fed black ash actually had much higher levels of survival than any other type of food source. And so speaking to the importance of that black ash leaf litter and influencing those food webs. Likewise, looking at amphibians, ironically, when the black ash dies, it creates more ponding and actually more sunlight, which is a good thing for breeding habitat for at least the amphibians that we've been monitoring in Minnesota. But the drawback is that many of these amphibians in the non-breeding seasons actually need forested wetlands with intact canopies. And so even though at least some of the initial impacts of EAB might be positive in terms of more ponding water, more kind of productivity of these wetlands, when those amphibians are dispersing into non-breeding areas, there's certainly some concern. Similar to that, looking at wildlife, this is some work that Alexis Grindy at University of Minnesota Duluth has been leading. We've been looking at small mammal communities as well as bird communities, and also larger mammals. And the figure that you're looking at here are based on camera traps, looking at just what's found in areas that have intact ash forest and areas where the ash had been removed. And generally, as you'd expect, some of these species like white-tailed deer are kind of indifferent to it. But there are species like fisher, as well as marten, that really avoided these areas where ash had been removed. And so as we think about at the landscape scale, the mortality of ash and the loss of that forested cover in these areas can really serve as a fragmenting feature that really influences the movement and kind of how these species might spread through the landscape. And what we see in terms of how these places change is that when you lose that ash transpiration, kind of the use of that water, that rise in the water table really shifts things from this forested wetland condition to much more of a marsh-like condition. Again, kind of a fragmented type feature. And what's unique about black ash forests relative to any other forest in the Lake States region is these have the highest number of understory plants found in them. And the reason for that, again, is if you think about where black ash forests sit relative to other forest systems, they're just a nudge below sugar maple forests. And so they contain a mix of both upland rich species as well as these wetland species that creates this very high level of diversity. But once you lose that ash, this is an example of an area where ash has been harvested. You can see the ash stump sprouts. That saturation really causes species like lake sedge, you can see here, that are in low abundance, to become very abundant and dominate the site and really change the overall structure of that system. So really create some challenges. So when we think about why you should be concerned, hopefully this brief presentation adds to what we already know is such an important, unique cultural value of black ash. And again, to acknowledging the Wabanaki people in Maine, as they often call brown ash, and its role in both their oral traditions as well as cultural lifeways. But also there's a unique role black ash and these black ash wetlands play in the landscape. And in the uplands, when we think about losing white ash, there's many other species that can grow well in an upland setting. But when we look at these lowlands, the reason why we should be concerned is that we don't see a high level of species that have the same adaptations and the same ability to occupy these sites following the loss of ash. And so both building on the next presentation, that's the True Rockstar that's going to take over, as well as certainly other talks throughout this webinar series, one of our real challenges is that how do we maintain these sites and maintain those functions, understanding that we very likely will lose black ash from some portions of the landscape and have these changes. And so that certainly is the grand challenge that we're all here to learn about. And I appreciate people taking some time today to hear some of this unfortunate gloom and doom, but also hopefully gained a bit more appreciation for just how amazing these areas are in the landscape. All right, and I will stop there and pass it off.
Okay, well, thanks a lot, Tony. That was fantastic. Great overview of what we're after. Sorry, I guess I hear that my screen might be breaking up a lot, and I'm sorry for that. Hopefully, some of this is getting through at least. But we will move on to our next rock star, Dr. Deborah McCull. Deborah holds a master's degree in forestry from Northern Arizona University and a doctorate in entomology from the University of Minnesota. Currently, Deb is a professor of both entomology and forestry at Michigan State University. And her research focuses on ecology, impacts, and management of native and invasive forest insects. Through this work, she has published an amazing more than 120 papers and 250 non-peer-reviewed articles and bulletins. That's a lot. It's a lot of work. She is also a member of the National Forest Research Advisory Committee, the Science Advisory Board of American Forests, and the Michigan Forest Invasive Species Committee. So please, let's all welcome Deborah.
Thank you, Paul. There we go. I'm going to trust everyone seeing my screen. Are we good to go?
Yes, good to go.
Tina. All right. So first off, thanks for the nice introduction, Paul and Lacey, for organizing all of this. If you've ever done one of these kinds of things, it's just a ton of work. And thirdly, I think that Tony D'Amato needs a better idea of what a rock star is. Maybe he needs to get out more, something like that. Anyway, you know, I've given a lot of emerald ash borer presentations over the years, and it's hard to get away from doom and gloom. I always try to find something positive, or, you know, someplace where we've made progress. And that's what I'm trying to do here a little bit. And we'll touch on that and then probably end up being depressed at the end. So I want to point out my co-author here, Patrick Engelken, was a graduate student at MSU and then kept working on a big black ash project we have underway in collaboration with Nate Siegert that you heard Tony mention. And Patrick's now a forest entomologist with the Forest Service out of the St. Paul field office. So lots of people have been involved in our ash borer and ash projects over the years. I'm going to show you lots of Patrick's data, some of the data that Molly Robinette collected. Justin, Nate's been very involved in this. And of course, we have to recognize the people that fund this work, APHIS, particularly in the case of our black ash work. So as Tony said, we've had a lot of years now with emerald ash borer. It was first discovered in Southeast Michigan, the greater Detroit area in 2002, June of 2002. And my one little claim to fame is I think I cut down the first ash tree to look at emerald ash borer. So whatever that's worth. We know it was present in Southeast Michigan for at least 10 years before it was discovered. We have a tree ring study that showed that. And if you look at where we know ash borer is today, 35 states, 5 Canadian provinces, nobody really knows how many ash trees have been killed. We just say hundreds of millions, and we're probably in the ballpark. When I was trying to organize this little presentation today, I thought this might be a way to do it. I hear a lot of people say a lot of things about EAB and ash trees and managing EAB and so forth. So I thought I would start with some of these statements that I hear more often than not, and kind of go through them one at a time and see where we are currently, whether we've progressed and what the status might be. So hang on, I'm going to try to cover a lot of ground. Some of it's going to be fairly quick and dirty. I know there's a lot more information coming out about parasitoids in webinars later, but let's get going here. So I should say the first statement that just makes me crazy is that there's nothing we can do but sit back. EAB is going to kill all the ash trees. They're all going to die. And I know that in some cases that's going to be true, and that there's practical reasons where trees cannot be treated with systemic insecticides. But in fact, you might be surprised at how many trees in wooded areas, for example, not just landscape trees, but other kinds of situations are being treated with systemic insecticides. Our knowledge of what beetles do and how to best control them, our chemistry that we have available, the application methods for some of these products, these have improved tremendously over the last decade. And you know, there's organic materials you can use. Most of these have to be applied every year, at least during the years when ash borer densities are high. But if you look at emamectin benzoate, products like Triage, that was the first one. Arbormectin is now sold by Rainbow out of Minnesota. We have really good data from a lot of trees and a lot of studies, some that we did, some that other folks have done. And if you treat trees at the lowest rate on the label every 3 years, the trees can be protected indefinitely from emerald ash borer. And this is a product that's not, some people I believe think it's incredibly toxic to people and other organisms, and it's not. You don't want to get it in your eye, but it happens to be very toxic to this particular beetle. And so there's different ways to use some of these insecticides. Lots of information is available. Basically, you can protect pretty much any tree that you really want to protect. And this can be simply treating trees in landscapes, individual trees that have value to a property owner. But a lot of what's going on is trying to treat at least a few trees, what my friend Kelly Church would call grandfather trees, that are good seed producers. And some of this is being done on tribal lands. Some of it is being done, I know the Pennsylvania Department of Conservation and Natural Resources is treating their white ash seed orchard to maintain the diversity and the ability to perhaps someday make use of that genetic diversity. There's ways to integrate these systemic insecticides with other kinds of approaches. I know that there are a couple of cities, and I more recently talked to some folks in northern Minnesota. They have ash trees they're going to remove. They already plan to remove them, and they're looking at using them as lethal trap trees, where they basically inject them with an insecticide like emamectin benzoate, give it a few days to get up into the canopy, come back and girdle the trees, which makes these trees very attractive to emerald ash borer. The beetles will visit the trees to nibble on the leaves. If the females survive that, which they probably won't, if they lay eggs on those trees, the larvae will be killed and controlled. And it's a way of amplifying the effects of treating, you know, one tree in the midst of other trees, for example. Larger scale, there's places like the city of Montreal that is mixing girdle trees to attract beetles to a specific area or to a specific tree. injecting other trees, just trying to increase the chances that a beetle is going to encounter a toxic tree. And that gives you the option of keeping the EAB population from blowing up. You're not going to get rid of EAB that way. It's just a matter of extending that period between the point where EAB invades an area and the point, what I'm going to call post-invasion forests, where you're looking at the aftermath of what EAB does. Biocontrol, there's a lot of people that know about Asian parasitoids, little tiny wasps that have been imported and are being reared and released, and their ability to go after EAB, and this idea that if you can release parasitoids, you won't have to worry about EAB because these parasitoids will take care of them. Federal agencies, particularly USDA APHIS, along with ARS, that's the Agricultural Research Service, and the Forest Service, have put a lot of effort into foreign exploration, where they go look at the forests in China and Korea, and more recently in Eastern Russia, where EAB is native. And they are currently rearing and releasing 4 different parasitoids, all of them introduced. The Spatheus agrilli was one of the first parasitoids. It attacks EAB larvae. It is not very cold hardy, so it doesn't make a lot of sense to release this in places like Michigan, Wisconsin, and certainly Minnesota. Spatheus galeni is related, obviously, and it is from Eastern Russia. It seems to be a little more difficult to rear, but it is cold hardy, and so that's another larval parasitoid. Tetrasticus planopinnus is one of the first parasitoids that was brought in from China. It's an interesting little insect. It disperses well. The adults are good flyers, and one parasitoid egg can produce multiple parasitoid larvae. Okay, it's a process called polyembryony, and the egg that the parasitoid female lays into the EAB larva divides into multiple embryos, and you get a situation like you see in that picture there. Oobius is an egg parasitoid, also native to China. A tiny little insect. The larva develops inside the egg of an EAB, therefore killing the egg. And I think we should always remember that there are lots of native natural enemies of EAB out there as well. Woodpeckers prey on the large larvae late in the fall, so usually starting about the middle of November and continuing through the winter. When they're just beneath the bark, typically maybe half an inch or so down. And that's what woodpeckers are digging out during the winter. You'll see them rake the bark and tear off huge chunks of bark. It's just amazing what even the small little hairy woodpeckers can do. They are still the most common and most important mortality factor of emerald ash borer. There are native parasitoids, okay, much like the introduced parasitoids, that will attack typically a pretty broad range of the phloem feeding insects. Those are the ones that feed on phloem, the inner bark, okay, so that area of tissue between the wood and the outer bark. And those of you that aren't familiar with parasitoids, I'll show you here. This is an EAB larva, okay? I hope you can see my cursor. This is the head of the larva. This is a parasitoid larva, okay? So the female has laid an egg on this EAB larva. The parasitoid is now feeding on all the good stuff inside the EAB larva. It's going to eat the muscles, the fat bodies. It will leave the digestive system and the respiratory system till the end, because it wants that larva to stay alive until it finishes its own development. And then this little wormy looking thing will pupate, and you'll get this kind of cool looking little parasitoid adult like you see here. So, very briefly, I'm not going to get into this too much unless people have questions. Things are going pretty well, I would say, in terms of rearing and releasing these parasitoids. APHIS has really worked out good methods for rearing them. There is good information coming in from some of these release sites showing that one or two or sometimes 3 of these introduced parasitoids are becoming established. And we still have the woodpeckers and the native parasitoids out there attacking EAB as well. So if you're a glass is half full kind of person, this is all good news. The other side of the coin, the more challenging glass is half full, is that while these insects are attacking larvae and eggs in some cases, there's really no good information, no good data showing that these natural enemies change the course of an EAB invasion wave. In other words, they don't slow the rate at which the ash trees are going to die. Maybe the best parasitoid, that little Tetrasticus, is limited. It's a small insect, and her little ovipositor will go through thin bark, but it won't get through thick bark. And so there's a lot of reason to believe that especially these introduced parasitoids may be more important in post-invasion forests, where what you have are a lot of recruits, what we call recruits, trees that are like 1 to 4 inches in diameter, and then some of the smaller saplings. There's also an idea that if you're going to use systemic insecticides, biocontrol, you don't want to do both. You don't want to interfere with biocontrol, or if you're going to release parasitoids and count on biocontrol, you shouldn't be using insecticides. In fact, they're very compatible, and I would really encourage, people that are trying to protect a given area, whether it's their own property, a woodlot, whatever the case may be. Woodpeckers will not attack dead EAB larvae. The parasitoids that attack larvae will not attack a dead EAB larva. The parasitoids, whether they're egg or larval parasitoids, will not be exposed to the systemic insecticides that you actually apply into the tree. And so there's reason to think even that combining the two tactics, and we've tested this, we have projects underway in a big forested area where we've tried to treat anywhere from 10 to 30% of the phloem, okay, the ash tissue that the insects need to develop on. We've treated trees with insecticide there, the imamectin benzoate, and what we see is that the population of EAB just stays low. It doesn't blow up. So that may be something, at least for a small area, that's worth considering. Now, to get into the meat of what I wanted to cover, all the ash species in North America, none of them have a coevolutionary history with emerald ash borer, and it's basically a matter of time until they're all killed. Well, maybe, maybe not. If you look at where emerald ash borer is established, and you look at the 4 main species that grow there, green, white, black, and blue ash, we actually have quite a bit of data from there. And what we see is consistently, there are some ash species that EAB prefers. Maybe they're a little more resistant. There are some ash species that EAB doesn't prefer. And if you think about how that works, the trees that the females lay their eggs on, the larvae are going to have to feed on those trees. They don't get to choose. And so these preferences that are exhibited by the adult beetles who have to nibble on ash leaves throughout their lifespan, and then the trees that the female lays her eggs on, are going to largely drive the impacts of what happens when EAB invades an area. And this, to me, this was a study we did. We set up a plantation in a research area not far from the campus here in Michigan. And we set up blocks of 5 ash species. So we had, every block had a black ash, a blue ash, a green ash, a white ash, and a Manchurican ash. That's a species native to China that's quite resistant to EAB. And the order of those trees was randomized. And then the next block, we did it again, all 5 species, random order, and so on. We had 21 of those blocks. We let the trees grow until they were somewhere around 4 or 5 inches in diameter. And then we exposed them to just the local population of EAB. And in the fall, we peeled the bark off of them. And we can count how many galleries that were on each of the trees excavated by the larvae, and we counted how many live larvae were on the trees. And what we see is that green ash and black ash were highly preferred. Every single tree was killed. And if you look at the number of galleries there, it's in the neighborhood of about over 200. So it's about 210, 220 galleries per square meter of phloem. Okay, so if you took that inner bark off of a tree and you spread it out and it was a square meter, 39 inches by 39 inches, you can get almost 100 EAB beetles to develop on a square meter of ash phloem. Okay, and then if you look over at this graph over here, the number of live larvae was a lot lower, mostly because they ran out of phloem. They attacked those green ash and black ash trees so hard that most of the larvae actually died just because of starvation. White ash, that's the purple bars here, you know, it was an intermediate species. Some of them were heavily attacked. There was about 7 that were heavily attacked and likely would have died if we hadn't peeled the bark off. Blue ash and Manchurican ash, beetles could not have cared less. They actually flew around those trees to get to the black ash and the green ash. So if you look at what we find out in the woods, blue ash, and there's some of this in southern Wisconsin, it does not come up, its native range does not go very far north. We get some in southern Michigan, Ontario, southern Ontario has some, Illinois, Ohio, Kentucky, they have a lot of it. It's a different kind of species. It grows typically on upland soils, kind of a cool tree, doesn't grow as fast as something like green ash or black ash, but it's a nice ash tree. And it is doing pretty darn well, even in areas where ash borer has been present for more than 20 years. These are data from 2 wooded areas that were over in Southeast Michigan, kind of near Ann Arbor, if you know where that is. We inventoried every single ash tree in both of these areas, more than 300 ash in one area, more than 500 in the other. Every white ash tree that was bigger than 2 inches had been killed by EAB. But the blue ash looked good. 60 to 70% of them were still alive. The ones that had been killed were pretty much suppressed trees. In a couple of cases, it was trees in flooded areas. Blue ash doesn't do well in flooded areas. And, you know, other people are getting the same kind of data. Ontario's got some of this, and blue ash looks good. White ash, it's a coin flip. It's kind of in the middle. It's the one that makes really nice timber. It grows often in nice sites. A lot of times you'll find it makes up a relatively minor component of the forest. Like Tony was saying, it mixes with a lot of other species. We went back in 2015 and 2016, and we had 28 different areas. These were large forested parks, game areas, and so forth. And this is the core of the EAB invasion here. So 15 or more years of EAB presence, and at least 10 or 12 years of EAB over in this area. We counted all the trees by species, looked at regeneration, looked at the condition of the trees, and so forth. And what we found, and keep in mind, these were trees, we picked areas where there was a concentration of white ash. So these were not big, nice, mature forests where there's just a few scattered white ash. These were areas where there was lots of white ash in close proximity to each other. But most of the trees in most of the sites are alive, and they mostly look healthy. So 24 of the 28 sites, more than half of the trees were alive. A lot of the basal area is still alive. 4 sites, there was almost no survival. Another thing that we saw is a lot of these old wounds left by EAB larvae feeding on the trees. These are the trunks of a couple of these trees, and the trees are recovering. They're putting new wood and new bark over those old wounds. And so, you know, I don't know what the long-term outlook is for these trees, but they have certainly survived with EAB for more than 20 years now in a lot of cases. So I guess we'll have to wait and see how that book ends, but so far, so good. Now we get to green ash, and the situation starts getting a little bit more bleak. This is a highly preferred EAB host. We saw that in our plantation study, and we see it over and over again. This is a tree that often co-occurs with black ash in a lot of our forests in Michigan. It tolerates those flooded, heavy soils. And whether you're looking at street trees or out in the woods or in our plantations, if you have both green ash and white ash, the green ash is going to get hit first, and it's going to get hit harder. And if you look at these trees, these are galleries, larval galleries per square meter. These are trees. This is green ash. This is green ash that was girdled. This is white ash. This is white ash that was girdled. These were little trees. Every other tree was a green ash. So it was green ash, white ash, green ash, white ash. And you can see just how hard the green ash get hammered. And yeah, the beetles, they'll lay eggs and develop just fine on white ash, but they'd much rather have that green ash. This is an area where we got a bunch of data over a long period of time, scientifically speaking, in terms of how we can do research. Each of these blocks is 40 acres, okay? This is state land in the center part of northern Lower Michigan. And this is Jasper 3, Jasper 5, and Jasper 8. This was all in Jasper Township. And in 2007 and 2008, we did 100% inventory of the ash trees in all 9 of these blocks. In Jasper 3 and Jasper 5, every year through 2014, we cut down at least 8 trees, debarked them, looked at larval density. And then in Jasper 8, we didn't cut any trees down. We just did another inventory in 2015 and went back in 2019 and again tallied up the ash trees and looked at the condition of them. This is from Jasper 3 and 5 where we cut down and debarked the trees, and what you see, this is larvae per square meter. Early on, the density was really, really low. This is where the larvae are taking 2 years to develop for the most part. And then the density starts to blow up, and then it increases exponentially. And now up here is where you have lots of some dead trees, lots of dying trees, some trees that you know are going to be dead soon. If you look at the numbers of live trees over here, this is Jasper 3. This was in 2007. We had almost 1,500 trees. Almost none are left. We had more than 2,000 trees in Jasper 5, almost none are left. 90 and 99% of the green ash phloem is gone. It's been killed. There are saplings and there are recruits. There is regeneration in these areas. Some of the recruits had been colonized when we were in there last summer, but a lot of them are still alive. The question is whether they're going to be able to get to the canopy, because young ash seedlings, saplings, they're pretty tolerant of shade. They get less and less tolerant of shade as they grow and mature. And if other tree species fill in the canopy gaps left by the dead ash trees, those young ash trees are not going to make it back to the overstory. So we'll have to basically see how that goes over time. This is data from Jasper 8. You can see numbers there in 2007, just as EAB had gotten established. I mean, really, if not the first year, at least the second year EAB had invaded there, we had lots of ash trees, 1,600, lots of phloem area. This is based on the size of the trees. The potential number of adult beetles that could have been produced based on the size and number of live trees was over 750,000 beetles. 200 and some ash trees per hectare. As with any area, most of the trees were small, but we had quite a bit of large trees in there too. Mid-invasion, this is 2015. We still have quite a few live trees. The phloem area is less than half, and that's because a lot of big trees have been killed by 2015. If you look at, where'd my cursor go? We're losing our carrying capacity, the stem density, not that different, but a higher proportion of the trees are little. If you look at what we saw in 2019, we're down to 181 ash trees, almost no phloem area. Potential production of EAB adults is way, way, way down. Stem density is down, and all the trees that are alive are little. Less than 13 centimeters in diameter, so less than 6 inches. The phloem that was available in 2007, more than half of it was gone by 2015, 98% of it was gone by 2019. There's still a lot of green ash seedlings. There's not very many ash borers now. The capacity to produce ash borers is much lower. Will those seedlings and saplings survive? Will they become overstory trees? I don't know, it may be 20 years before we can really answer that question. These are the trees though that where the parasitoids might become important, where you have a lot of saplings, small trees, that's good for the parasitoids. And finally, I hope you're still with me, we get to black ash, which is highly preferred. Beetles love black ash. Even when it's really healthy and growing in a really nice site with just the right amounts of water, the beetles still really love it. And Tony went over a lot of the ecology. Every time I listen to Tony, I learn new stuff. So I think we're all pretty much interested in black ash here. It is not only highly preferred, based on our experience, we think that it's the most vulnerable of the ash species EAB has encountered to date. And that is because EAB larvae tend to feed horizontally, back and forth, back and forth. These galleries are wider. And what happens is each larva kills more tissue on a black ash tree than they do on something like a green ash tree. And that means that it takes fewer larvae to kill a black ash tree of the same size as a green ash tree. And that's not a good thing. I think we can all agree with that. Some of you, I just point this out a little bit. This is Renee Dillard. She's up around Mount Pleasant. Not only an incredible basket maker, but she does a lot of teaching of the youth up there about how to collect and process black ash and weave these beautiful baskets. This is John Pigeon. Some of you may know John. He and his family are longtime basket makers. This is data that Patrick collected last summer. You guys are the first people to see it. We went back to 30 different areas. You can see a map, all in Lower Michigan. We couldn't do any overnight travel to speak of because of the COVID stuff, but we went into these sites. All of them had at least about an acre. Some of them were really large sites, in which case we delineated 20 acres to do our surveys, and we looked at trees, we looked at regeneration, we looked at the coarse woody debris, the fallen trees, and so forth. And as you might expect, there actually was quite a lot of live trees. There was even more dead trees. Most of the trees that are alive are not ash trees, and very few of the trees that are dead are ash trees. There is now a total of 12 black ash in those 30 sites, 8 live green ash. Most of them are dead. You can see, look at the numbers there yourself. The live black ash, that there was a total of 5 sites that had at least one live black ash tree. And I should say, these are trees that are at least 4 inches in diameter, okay? So on average, they were about 17 centimeters in diameter. That's somewhere around 7, 8 inches in diameter. Same for the green ash. A couple of white ashes were in those areas. But if you look at the basal area, we can estimate the pre-EAB basal area. Okay, so this is all species. This is what's currently alive in these 30 sites. This is the ash basal area that's currently alive. Okay. And you see what EAB has done in some of these areas, in all of these areas, not some of them, all of them. This is looking just at green ash here, black ash here, pre-EAB green ash. That would be the live standing trees plus the dead standing trees plus the fallen ash logs, the green ash logs that were clearly killed by EAB. Almost nothing left. Same for black ash, and we picked these sites because they were dominated by black ash originally. You know, pretty nice basal area there, almost gone, 98, 99% mortality. So trying to find something good to say about that gets a little bit more difficult. The recruits, okay, these are 1 to 4 inches in size. You look at all the species, that's what we have here. This is all the ash recruits. This is black ash recruits. The happy thing is that 25 of the 30 sites had black ash recruits, live black ash recruits, and that seems really good. This is saplings, so a little bit smaller, less than 1 inch in diameter, but more than 3 feet or so tall. Lots of saplings here, and most of them are ash, and more than half of them are black ash. Okay, the rest are green ash. So that's not looking too bad. I actually was really surprised that there was that much live regeneration coming back in these areas. And I want to point out, these were all recruits and saplings that had originated from seed. There was virtually no live stump sprouts on any of these dead black ash trees. And I think, Tony showed a picture of trees that had been harvested and had this prolific profusion of stump sprouts coming off of them. And I think that happens when you cut a healthy tree. But when ash borer kills a tree, that's something that happens over a period of years. It could be maybe as few as 2 or 3 years, but more likely 3, 4, 5, 6 years before the tree dies. And they just they kind of starve to death over time. They lose their vigor. They don't have energy. They just really can't push out stump sprouts. So let's see, we got no stump sprouts, but we do have live recruits and saplings. There isn't much of a carrying capacity for EAB. The big trees are all dead. And the question becomes whether these young trees can survive. And something I'm going to toss out there for the great minds to think about, and especially the silviculture people, in terms of restoration or protection, those young trees out there, maybe that's where the effort should be. Maybe that's where the focus should be. I don't know, just something to think about. Real quickly, I wanted to show you a little bit. Tony and I, we couldn't have planned our talks better if we had tried, I think. Black ash and green ash so often are in riparian forests that line streams and rivers and lakes. And ash leaf litter, like Tony said, it's a really high quality leaf litter. It doesn't have a lot of lignin. You know how oak leaves are really tough and they don't decompose very fast. Ash leaves, when they fall off, they decompose quickly. They have a lot of nutrients in them. Everybody likes ash leaves if you're going to feed either on the terrestrial side or in the water, invertebrates and insects and so forth. One of the things Patrick did was to look at 3 rivers in northwest lower Michigan. If you salmon fish or steelhead fish, you probably know of these rivers, the Betsy and Platte and Little Manistee. Very important recreationally, both in terms of fish habitat, and people love to kayak and tube and canoe down them. And one of the things we did early on was to get aerial imagery, publicly available aerial images, and kind of do a time lapse sort of deal and look at these, the entire stretches of the river, and look at as followed the ash trees dying, I guess is the best way to say it. So in 2010, you can see it's blurry, but all these areas, these are live ash trees. This is 2015. You're seeing ash mortality here. This is 2018. All of this dead stuff in here is dead ash. And so we looked at these gaps along all 3 rivers. And then Patrick and Justin went down stretches of each of the rivers. They would go into a canopy gap that we had found with the aerial images, measure all kinds of things about trees and coarse woody debris and regeneration. And then either across the river or on either side of each of these gaps, they went into the forest and took the same kinds of data. And I'll just kind of cut to the chase. The gaps that we see in those aerial images are in fact caused by dead ash trees. Originally, green ash and black ash together made up anywhere from 40 to 70% of the basal area of the overstory. What is there now is no live black ash, no live green ash. There were 6 white ash trees that were still alive in there. More than 95% of the ash trees, again, greater than 4 inches, are now dead, and you get these big gaps. In between the gaps, you just don't have ash. That's why they're not gaps, okay? Across the 3 rivers, we were able to tally 400 and some different canopy gaps. And what I think is just amazing is that within 100 meters of the banks of all 3 rivers, anywhere from 13 to 20% of that riparian forest area is no longer forest. It's a canopy gap. It's an unshaded gap full of dead trees. About 3.6 to 7 gaps per kilometer. So a kilometer is roughly 0.6 miles. So again, that's about 3.5 to 7 gaps per half mile. As you move away from the river, if you get more than 100 meters away from the river, there's no ash. Okay, so we don't have gaps going very far inland. They're just right along the rivers. There were some green ash saplings alive. Again, that may be our hope for regeneration. There was no live black ash saplings. There was almost no ash seedlings, nor tree seedlings of any species, because these gaps are getting filled in with these dense mats of sedges now. And again, almost zero stump sprouts on any of the dead trees. Few green ash trees had a few live stump sprouts. None of the black ash did. So bad news for riparian forest, bad news for black ash, pretty bad news for green ash. A lot of this is what Tony was pointing out. You lose this leaf litter input. You're going to have this big pulse of coarse woody debris going into these streams and rivers. You're losing the shade. We're not seeing any black ash regeneration in a lot of these riparian areas. So to wrap it up, thank you for hanging with me. The ash trees, facts and fictions and EAB, and what do we think? First off, there's a big, not every ash tree is the same. Blue ash looks like it's going to be okay. If it's on a healthy site and they don't get stressed by anything, I think they will coexist with EAB. White ash is a toss-up. Lots and lots of dead white ash trees out there, but also lots of alive white ash trees. Maybe they can persist with a low density of EAB. Black and green ash, preferred and vulnerable. Outlook is maybe not so good. There are these highly effective systemic insecticides. There's different ways to use them depending on your objectives. Biocontrol is going to help native and Asian parasitoids, but that's not going to keep the trees from dying. And so far it hasn't even slowed down the rate at which trees die. You can use insecticides, you can integrate them with biocontrol and other kinds of management strategies. You just have to think about it and plan it and figure out how to do it and pay for it. This last one, forests are resilient. I've heard this, you know, nature has a way of overcoming things. Post-invasion forests will recover. It's hard to say that black ash, there's just nothing very rosy for black ash, other than the fact that we still have quite a bit of regeneration in most of those sites that we looked at this year. So with that, thanks again for hanging with me, and I'm done.
All right, well, thanks a lot, Deb. That was fantastic, and I really liked the organizational. That was a fun presentation to listen to.
Thank you, Paul.
Yeah. So, and yeah, did you and Tony talk to each other? Because that linked up really nice.
It must have been signals we were sending to the air or something.
But I guess up next, we're going to do about a 5-minute break so that the hosts can kind of gather up the panel questions. If anybody has any more questions they'd like to ask our experts here, please put them in the Q&A tab at the bottom. And we'll come back at, what time is it? It is 2:18. Let's do 2:25. We'll start the Q&A section. All right. Thanks, everybody. So thanks again, Tony and Deb. Are you guys ready to field some questions?
You betcha.
All right. Okay, so the first one I got is from Phil Segan. What are the top 3 species in each the wet versus very wet species categories shown in the non-ash species graph? I believe this is related to one of your slides, Tony. You know what that's talking about?
Yeah, so in that work, and I can pass along kind of the paper with that, but the top 3 varied in terms of which was more dominant, but across in terms of frequency, it was northern white cedar, American elm, which unfortunately you see a bunch in there, but as we all know, Dutch elm disease kind of limits that. And then the other species that we saw a lot was balsam fir, and that's pretty much a Minnesota picture. As you move into Wisconsin and certainly into Michigan, again, hemlock gets picked up a bit more, and red maple, but In those areas, those were the most common. And in between the very wet, a little bit more, cedar was a little bit more of the dominant on the very wet, and then American elm was a little bit more of the dominant on the wet, if you're going to rank those three. But yeah, they were generally still well below much of the percentage. And as Deb pointed out, if we look at regeneration, there was still black ash in those regeneration. These are intact stands, so that it's in those sites, mostly in the regen layer.
I might,
Okay,
and just to
great.
follow up there a little bit,
Next,
your screen froze a little bit, so I jumped in, sorry.
oh, you're good.
I would, I think Minnesota has extensive areas of black ash, and we have some of those, but we also have a lot of smaller, almost like patches of black ash. And I know, looking at the data Patrick got last summer, there was an incredible variety of species that were co-occurring with black ash, balsam fir and white cedar up north, a lot of soft maple, silver maple in particular, occasionally white pine, where you had just a little bit of a rise. And then I just want to point out there was a couple of locations in southwest lower Michigan where the dominant species was poison sumac. I didn't even know we had it. So that was awesome.
You know now, though, huh?
Well, Patrick does.
All right, thanks. Next question is for you, Deb, from Tom Milnerick. I see the woodpeckers scaling on ash. Is it safe to assume that they're after EAB, or are there other parasites they might be after?
I would say there's a 99.98% chance your tree's got lots of EAB on it. There's really no native insects that will colonize a tree at the density that EAB does. There's things like red ash borers, but they get into a tree once it's dead, and they just don't reach those densities. And woodpeckers are so good at finding infested trees. I don't know, I'd like to know how many new infestations were found because somebody noticed woodpecker feeding on a tree. I know that's how Ohio found their very first infestation, was somebody saw woodpeckers just pounding away on an ash tree on their property.
Yeah, I've seen it a few times. It's amazingly obvious when you see it.
Especially when there's snow on the ground, they're just ripping those chunks of bark off. It's incredible.
Okay, I guess along the same lines, we have a question for you, Deb. Do woodpeckers eat the parasitoid larvae, so the ones we're biocontrol releasing?
Yeah, I saw that come up in the Q&A list. That's a really good question, whoever asked that. And I was thinking about that, and I would say by and large, no. And it's not impossible that it could happen, but it would be unlikely, and it would be a very low proportion. And the reason has to do with the biology of the parasitoids. They want adults to get out relatively quickly. Secondly, woodpeckers, they don't care anything about dead larvae, and they're not going to go after parasitoid larvae. They're just too small. You know, if you think of all the effort a woodpecker has to expend to pound through the outer bark and get into where the ash borer larvae, parasitized or not, is going to be, they're not going to waste it on a tiny little parasitoid larva. So I would say by and large, woodpeckers will get live, healthy, fat larvae that have finished their feeding, and they're kind of curled up in that overwintering kind of jackknife bent over stage. The parasitoids are going to be active at a different time of year. And I mean, it's not impossible, but I think there would be a really low proportion of parasitoid larvae that would ever get eaten by a woodpecker.
Cool, that's the different way than I would have thought of that. So cool. I guess we got another one for you, Deb, from Chris Borden. Maybe you know, in Michigan, is Trout Unlimited involved with reforestation efforts in riparian areas?
Boy, that's a good question, and not that I'm aware of. I think I'll reach out and ask him about that. The data that Patrick and we got on the riparian, those three rivers that I showed you, and then he has another big study that where we looked at riparian forests along 12 streams running from southeast to central to southwest lower Michigan, and found essentially the same kind of effect. I don't know that they are. I believe the national forest, the one that's up around Cadillac in northwest lower Michigan, is interested in doing some restoration work in riparian areas there. But yeah, that's a really good idea to let the Trout Unlimited people know about that.
Okay, let's see. We've got another question from Phil Segan. What is it about black ash bark that allows the larva to girdle longer horizontally compared to the other ash? Why do they make a different shape?
Yeah, that's a good question. My current hypothesis, I don't know, is the easy answer. What I think may be involved is that typically black ash are growing in really rough sites. You know, they're in a swampy, boggy sort of area, and that phloem is not very thick. And it may be that the larva has to make a really big gallery back and forth to get enough phloem to feed on. I see Tony nodding his head, and hopefully he's in concurrence with that. We've looked at the internal anatomy of different ash species. We've used, there's a technique you can use called scanning confocal laser microscopy, where you can get really close images of the cellular structure of different ash species. And black ash is a little bit different. You know, it tends to have bigger vessels, and there's a little bit different there. I don't know if that has anything to do with how ash borer larvae feed, or if it's just that the black ash are in harsh sites and the phloem's not very thick, and the larvae just have to feed and feed and feed to get enough nutrients to develop. Tony, you want to weigh in there?
Yeah, and we don't have data on phloem per se, but when we looked at sapwood area in black ash, we had to check the numbers a few times because it's so much lower than many other species. Again, to Deb's point, in terms of the sites they grow on. And so there's often the notion that, well, black ash uses more water than any other species and keeps these areas from swamping, but it really doesn't have a huge area of sapwood. It just happens to be the tree that can grow there and use water in those spots. So I think you're onto something there, Deb, with that thinking, because we were pretty surprised with just how narrow that sapwood area was relative to most hardwood species that we've looked at.
Huh. That's interesting.
Yeah.
I'd never heard that before, that they go the other way on black ash. It's pretty cool. I mean, not for the ash, I guess. But. Okay, we got another question for Deb from Steve Garski. How much of a seed bank do black, green, and white ash have? Tony mentioned black ash seeds can lay dormant for up to 8 years or so.
So I'll give you my experience and what we've seen, and then I'm going to let Tony answer, because I think he's looked at different kinds of areas. We actually worked with folks out of Ohio State, and they had a network of plots set up in big forested areas in Southeast Michigan. And one of the things we did was to sample the seed bank. We took a big soil hammer, this thing you pound into the ground, and it gives you I don't know about that much of a soil core. And it turned into some nice undergraduate research projects, because it's kind of laborious. You get the soil out and you sift the soil and you get the seeds out, and then you see which ones are ash, and then you see which of those seeds are viable. And the bottom line was that the ash seeds were not persisting very long at all in the seed bank. I think maybe a couple years. The black ash and the green ash were probably the least persistent. Kind of a combination of decomposing, and I'm sure little animals eat. I mean, I know they eat them. They eat the good part of the seed. So my feeling based on what we saw there, is that the seed bank is not very persistent. I would also point out there's an insect called the ash seed weevil. And a few times where we've captured seed coming, good seed years, and you have a big tree that's loaded with seed, and you collect the seed, and then you look at it and you can see a little tiny round hole often if the seed has been weevilled. And, consistently we get really high rates of weevilled seeds. And that may just be part of where we're doing that kind of work. But I kind of wonder about the seed bank sometimes. On the other hand, we had those saplings and recruits and even some seedlings that Patrick tallied up last summer. They're all from seed. They came from somewhere. So Tony, you want to talk about?
I was going to defer to Wendy Klooster's work that Deb was involved. I mean, it's really the best study that's out there. Really does a great job looking at both seed bank, density of seeds, and then also like persistence over time. And to Deb's point, I always think there's such high predation on those seeds before they even hit the ground. But then once they do, functionally, we think of 1 to 2 years is kind of a good window. The 8 years is kind of what folks have shown as the potential, but generally, especially both with white ash, the work we've done, as well as with black ash, 2 years seems to be kind of those that survive that first filter, which is they get eaten by something before they even drop from the tree. That seems to be what is kind of the average survival. So that 8 years is kind of the upper end of it. And once they establish, kind of as Deb's pointed out, I mean, it's kind of, now you have something to work with there, but there's a pretty big bottleneck to get to that point. And once the trees die and you lose that seed rain, again, I'm just picturing the figure from that paper that Deb worked on, you can kind of see that density of seed per unit area. So if you're trying to keep that seed bank, the first part is listen to some of Deb's strategies and how do you even keep the trees alive on the site to produce seed and maintain that over time. But on average, we'd say if the seed survives the predation, like it seems 2 years is kind of a typical window that they can survive in the duff layer.
I might follow up, and maybe this is going to be covered in other webinars, and maybe most of the people on this webinar are already aware of this, but there are efforts to collect seed across the range of the native species, and particularly black ash seed, and to preserve it. And there are mechanisms for doing that. And I know some of the tribes in Michigan are collecting and preserving seed themselves. Others are working with the ARS lab, and they will x-ray the seed and make sure that it's intact and it hasn't been weevilled or fungused up. And then they will, they have long-term storage facilities that are incredibly temperature controlled and everything, and they can save that seed for who knows how long. So if that hasn't started to any degree in Wisconsin, I would really encourage people to consider that. And it's a nice time. You go out, you have a picnic, you collect some seed. It's good.
Yeah, I know some of the tribes here in Wisconsin have started, and during week 3, we'll have Stephanie Green and Jeff Karstens from the ARS lab talking about that, how to collect, how to set up a system with them and send seed in. So yeah, we'll have more of that coming.
Yeah.
Let's see here. What have we got next? Got a question for Deb and Tony from Sunny Lucas. Do you see any hope of for black ash and or green ash with the resistance work that's being done and the efforts to collect lingering ash?
You can
just say no.
I think EAB and ash is really a challenge. I think that there probably, certainly there's chemistry that is involved in determining which trees the female beetles want to feed on and lay their eggs on. And I think that's really important. And just in terms of the scientific understanding of the interactions between emerald ash borer and ash species, both native and some of the species that it's co-evolved with, I think it's good to work on that and to understand it. In terms of restoration, using resistant ash stock, I don't know how practical that is, to be perfectly honest. I think about the sites where black and green ash were at one time dominant. And in most cases, there's so much of the sedges or there's other plants that have filled in. In some cases in forests, the non-ash trees have basically taken over those canopy gaps and filled it in. And so to do any kind of restoration there, you're going to have herbicide and kill off some competing vegetation. And then you're going to plant your resistant ash, and then the deer are going to come and eat them. So then you have to have deer fencing. And depending on, maybe not so much in riparian areas, but there's going to be probably some irrigation needs. And so on a limited basis, I think there's some potential there. I think you can probably create a tree for landscapes. On the other hand, we have blue ash now that works, is pretty resistant, as resistant as the Asian species we've tested. So, scientifically, I think it's very interesting in a practical sense in terms of, will we ever have black ash and green ash like we did pre-EAB? Probably not. Tony?
Yeah, I think your point, Deb, is a good one in that, the time frame that it would take to produce, I think there's, a resistant seedling that could be deployed operationally. We're pretty much against the clock at this point. I mean, once you lose ash from those stands, as Deb pointed out, and some of the stuff we've shown, it goes to a situation that's pretty tough to think about reforesting. And so maybe thinking more about can I hold this site or do things on this site that maintain some of those functions and maybe makes it a little bit easier to restore when those options come up. But I agree. I mean, the time frames we're looking at, if you look at American chestnut, white pine blister rust, obviously dealing more with a pathogen there, but they've been breeding for a long time. And there's always some challenges, even cold hardiness. We see with the maturing ash, doesn't have the cold tolerance. So even if it was resistant, it can't do as well across the area. So it's just, I think again, I endorse the science and endorse it as being part of what we're trying to do. But these sites, once they lose the species, it becomes really challenging to think about growing anything out there, let alone, whatever these species are like competitively once you breed the resistance into them. So I think thinking more about how do we maintain some of these functions, try to minimize the impact today, with part of that rationale being that it can make it easier to restore, these black ash too in the future. But I agree. I think it's maybe thinking more about long-term seed collection, protecting trees. Those strategies might make more sense.
Just one more little thing. I kind of asked a rhetorical question in one of those slides, and I was going so fast that it probably didn't even register. But in these post-invasion forests where we do have pretty good black ash regeneration, you have genetic diversity there, and you have trees that are adapted to be there. And I'm more and more thinking that maybe there should be some investments made there, and maybe that's a way to see what we can accomplish in terms of restoring, at least functionally, the role of black ash in some of these areas.
All right, kind of along the same lines, this is a question for me is, we talk a lot about the potential that, once you lose your ash, the system changes, and bringing it back to a forested situation might be very difficult. Do either of you have an idea on like what's the percentage of black ash basal area that, if you get to this threshold and they all die, we're going to swamp out? Or if, you only have 50% ash and 50% other stuff, maybe you'll be okay and it'll stay forested.
As Deb pointed out, I mean, the context that we've mostly worked in, both in Minnesota and Wisconsin, are probably more basin, larger areas, less within the kind of swales where you might have more upland species that can mix in. And in those situations, especially there was some work in Wisconsin looking at strip clear cutting, and so you kind of could get a handle on like what percentage of the stand had been cut. It seemed like once you got above 60% of that basal area removed, that you started to get swamping. Now, it doesn't mean it totally switched to something else, but it meant there were spots where you were losing tree cover. It was definitely going to be sedges and tag alder, and in some bigger basins, some folks that are using like larger like group selection, so up to a ½ acre opening. Even in those, they were seeing like swamping out in those opening sizes. So just thinking a little bit about but that's a big, those are basins. So that's a different scenario where the water table is pretty coupled to the trees. But, so I think it varies by site, but, trying to keep mature trees out there is, there's many good reasons for that, but it seems like not dropping below, 40% if you can at least hold some of that function there based on we only have so many data points in ash, but
yeah,
what we've looked at seems like that's what we've seen.
Okay, great. I've got another question from Paul Segan. For Deb, would it ever seem reasonable to strategically select and inject mature seed producing white ash in locations of high ecological value? Would the cost be too prohibitive for the return if seed origin establishment is the goal?
It's a really good question. Yes, I do think that's reasonable. And I do think that it could be practical. And I think, you know, we could talk about ways to kind of reduce the cost. The fact that you wouldn't, if you use the imamectin product, you wouldn't have to go in there and treat the trees every year. You could probably, you know, every 3 years when the EAB population is high, but maybe back off to every 4 years or maybe longer. I think it's a really good idea, actually. And Paul, I assume that you live in Wisconsin, but if you wanted to get in touch with me, I could give you all kinds of details and suggestions about how you might go about that and how to kind of try to spread your costs out over time and so forth. I'd be happy to do that. And I would love to see white ash persist in some of those high quality hardwood stands, you know, where you have scattered white ash, scattered big white ash. The places that I've been, those trees tend to be dead in Northwest Michigan, for example. And I think it's because you have an ash tree surrounded by non-ash trees. And so the ash borers tend to concentrate on that one big ash tree and you end up with dead trees. Where we see the high survival is where you have a big, not necessarily big, but a cluster of ash. It kind of maybe dilutes down the population to some degree. So I guess the answer to that question is yes, I think it's a good idea. And I do think you could work out the costs so that it would be practical.
Yeah, I guess we might hear some more about that in week 4 from the Menominee Tribal Enterprise folks. I know they are doing that right now with some, what they're calling legacy white ash. And I've seen them and they're crazy. They're like 30 to 34 inch DBH white ash that are just monsters in the middle of the forest. So I've heard they're keeping them alive.
That's awesome.
for the
That's
seed,
good for them.
So hopefully they'll talk about that in a couple weeks. It looks like Paul will be in touch with you as well. So
Yeah, sounds good.
another question: what is your silvicultural recommendation to a forest manager who manages white ash over a large spatial scale and can't afford to wait until trees are dying to react? This will also be covered in later weeks. We will hopefully have a pretty big section on this, but Deb will still let you give a crack at it.
I'll give you my short answer, and then Tony's more of a silviculture guy. My short answer is that if you have a good market for the white ash, you might as well make use of it. Nobody can, if you're not treating trees, nobody can guarantee that those trees are going to survive EAB. So if you're setting up a timber sale and there's interest in the white ash, or you can define your timber sale parameters such that you get some return on your investment or get some return for taking out the white ash, that's not a terrible idea. And if you take out the white ash and they're still healthy, you will likely get some stump sprouting coming back. So, you know, there's that to think about. And Tony?
Yeah, and you know, just to follow up on that, I think, and it goes back to some of what Deb's been describing in these mixed stands. You know, if you let EAB kill that tree, right? And we know white ash that crowns up above the canopy, it's not going to create a big canopy gap, and that's going to get filled by whether it's sugar maple or other species that are much more shade tolerant. So you kind of just taking the tree out, same deal. It's not going to create a big enough gap to regenerate white ash. But what I would recommend, you know, kind of building on what Deb said, is you cut those trees, certainly capitalize on the economic value, because, you know, at least on our side of the range, it's still a very strong market for white ash. But, you know, do it in a way that creates canopy gaps that are big enough to recruit it, because it's not, you know, it's a species that, as Deb mentioned in her presentation, they can tolerate shade when they're like knee high, but once they're like breast high, they have really high light requirements. So you're looking at a 1/3 acre kind of opening often for it to be able to compete in some of these stands that are really mixed. And so do it in a way that you're both removing the ash, but you're also recruiting it. So kind of package it as part of a regeneration harvest that thinks about future options and just knowing what we do about like some of those biocontrols are more effective on smaller individuals, and and also just future potential for the species out there. And then maybe leave a few out there just as a legacy to see what happens, because I always point to Deb's hopeful slice that she published recently that some white ash do survive. So maybe leave a few out there just to for genetic diversity, habitat. It's always one of the bigger trees in the stand, as we just discussed, so that large tree habitat, if it's a coarse tree that's not very economically viable, it could be a nice big log ultimately. So, but I would tie the removal to regeneration. Like, can you recruit new ash with that cut? It's kind of how we've been thinking about that in those more mixed, like mesic stands. And again, building off of what they found, through the group with Ohio that Deb worked with, that just let it die on its own, you're going to lose that regeneration fast.
Good point.
All right, thanks guys. And also it looks like week 4, that is the main focus of that entire session. So we'll hear a lot more on that, hopefully. Let's see, where my question list? This is for either of you from Kate Hegston. Do you find earthworms in black ash stands, and does it have a heavier effect due to the leaves being more nutrient rich versus other hardwoods? Seems like with a more nutrient rich leaf, it could exponentiate the earthworm population, leading to a faster decline in the stand's health.
I haven't, when I think of worms and ash, it's more in the white ash stands, or it seems to be, again, I don't think of worms as being as big an issue just because of the hydrology of those swamps. But what is interesting, and Deb's probably seen this too, is it seems like on those sites with heavy earthworm impacts, you get a lot of seedlings of white ash and occasionally black ash in the understory in those stands. And part of what at least we think could be going on there is, as I mentioned, the dormancy of that species of ash. It needs 2 cues, kind of warm, wet, followed by cool, wet. And so I wonder when it falls on that basically exposed humus layer that the worms create, is that just allowing ash to be more successful in germinating than it would have been if there was that nice intact duff layer? But so I always say this is kind of like sick and twisted. There's worms and now it's causing ash to regenerate. It's like the double whammy in these areas. But I don't, in the black ash swamps, I haven't thought of worms being an impact, but in these uplands, yeah, they cycle through that litter fast. And then ironically, it seems to lead to more ash regeneration for some reason. So I don't know, Deb, have you seen that in some of the sites you surveyed or?
Yeah, I would say I have nothing to bring to the table there. We a lot of entomologists have looked at what happens with ash logs when they fall. We have some data on cerambycid wood borers, the longhorn wood borers in post-invasion sites and things. But there's nothing that comes to mind related to worms. So I really have nothing useful to say.
I guess from Stockbridge's area, just anecdotally, in our heavy earthworm places, we have an amazing amount of white ash regeneration, almost 100%. I mean,
that's interesting.
The deer also love to browse it into the little bonsai trees, but there's a lot of it. The next question we got, Ginger Nickerson would like to know if the riparian canopy gap research has been published, and if so, what is the journal name? Or maybe you could just share it. We can put it in our supplemental stuff.
Yeah, I can send the references, the citations and stuff. The paper about the 3 northern rivers and the riparian areas there and all that was published in 2020. It's Ingleton and McCullough. I think it was in Canadian Journal of Forest Research. The paper that I mentioned, I didn't really talk about it, the 12 first order streams in southern central Michigan, where we measured a lot of the same things, but different sorts of habitats. That was published in 2020 in Forest Ecology and Management. And Tony, you've got a number of papers there too.
Yeah, and I'm happy to pass some stuff along, but less in that riparian context that Deb was talking about. But yeah, I can provide some material, including the one I mentioned on
You
what's.
can also provide Patrick's email address and he can send prints out.
Let's bring him into it.
Yeah, absolutely.
All right, and yeah, we will hopefully have a pretty lengthy supplemental document that'll be posted up on whitcac.org, so people can look back there for reference material and stuff. Next, we're winding down to the 3 o'clock hour. We got a couple left here. Jeff Sorensen would like to know, are there any recommendations on how many black ash seed trees to leave during a pre-salvage harvest and then protect chemically to maintain a viable seed source long term?
Boy, Tony, got any ideas?
Yeah, I mean, of course,
Specific number right now, go.
the key thing, as we all know, is not all ash produce seed, right? So it's a dioecious species. So definitely making sure you're protecting the females, when you're doing that. But yeah, I mean, I would probably go to more logistically, and economic, how many, could you afford to maintain track on the site? I mean, I think any ash seed in the site is better than none. And then from there you go, I think, in terms of the economics of it. And as Deb pointed out, with the systemics, it's not like you need to do it every year anymore, which is great from a cost-effective standpoint. But in terms of seed rain and seed coverage, if we were thinking about it in terms of like fully regenerating the site, like 10 to 15 per acre, but obviously logistically, that's probably not going to be feasible. So, it's not the most satisfying answer, but I think, more than zero, but your upper limit is probably going to be dictated by the, how economically viable is it to do that across the landscape. And so Deb, they're doing protection, Deb, which would, do you have a sense for the number they've been protecting?
My sense, I'm trying to think of a couple I know, where it's been basically individual trees, and the idea is to protect those trees and then collect the seed when there's a good seed year. If you were looking to maintain a larger ash component, as opposed to just collecting seed, that would be something to really think about and explore. I would bet that we could come up with some reasonable recommendations. I haven't ever tried to do that before, and a lot would depend on what other species are there and what's in the understory and that kind of thing. I do think that if you wanted to treat, again, like Tony said, it's going to depend on the cost, but you could get into a rotation where if you had the ability to treat, say, 20 trees a year, ultimately you could have 60 to 80 trees protected at any given time. And whether it would be best to spread those out or to concentrate them in a particularly important area for whatever reason, I think that would almost be a situation by situation type of deal. I think Tony might have some good ideas about trees per acre or concentrating those, but logistics and costs and what your objectives are, I think would all play into that.
If money wasn't an option, then maybe saying, if trying to provide that hydrologic function, then at least 40% of the stems out there you're trying to keep alive. But again, that's a huge ask if you're looking at a big area. But so maybe, I think Deb's context is good in terms of just the site conditions and what the probabilities of recruitment.
Okay. Devin, Tony, you guys still good for a few minutes if we do a few more?
Sure.
Yep.
Minutes at 3. Okay. We've got one from Philomena. Any hope that Tamarack can provide some functionality in these systems?
I'm trying to think. Not so much in the areas where we were in Michigan. Tony, do you see any?
It's funny. It's a species that was included. We'll talk about this, I guess, in a few weeks. We planted, to try to increase resilience of the stands. The thing about Tamarack is it likes a little more stability, in the water table. Those, ash is pretty, it's built for those hydrologic regimes and bounciness and unpredictability that, so Tamarack, at least on those larger basin sites, doesn't do well. There is a trial that Wisconsin DNR established where they planted a larger Tamarack and have had good success. And I, Colin Matula has been involved with that work. And so I think on some of those sites, they did do some pretty intensive site prep, to get, because it's a not the most competitive species when there's any type of shade, but to get it going out there. And we see it at low abundance in like the historic record, but yeah, it doesn't seem to be one that could like take over the site. I think it's something that could be part of a mix, but we've had really low survival, and but I know there has been at least some work done on a trial that Colleen, they documented pretty high success, was initially a planted tamarack on a site that did have ash on it historically.
So, and my feeling is you would have planted. I'm trying to think of any place I've seen where there was a mix of tamarack and black ash. I can't think of any. There probably are some somewhere, but I haven't seen them.
Yeah. I wish northern white cedar, I mean, that's the, and again, American elm, some of these trees are a bit more challenging for different reasons. Even hemlock, depending on where you are. But yeah, elm was probably 30% of some of the areas we worked in based on like historic records. So it'd be nice to have that still on the canopy.
Yeah, I would. We will also be talking more about this in week 4. And I could talk about that topic for the rest of the day, but unfortunately we should probably move on. Let's see, we got a comment from Colleen Matula. In Wisconsin, tamarack does well in open planted sites and on ash sites. So I guess.
Yeah, that's the trial that, yeah, it's done really well there. So I would definitely say it's got potential.
Great.
Let's see, we've got a question from Chris. Bounce around. Borski, have there been any known efforts to plant blue ash as a replacement species outside of its native range for white or black ash, specifically in the more northern ranges?
So, good question. And one of the things that we have going, we collaborated with Jeff Karstens, who's going to talk about the ARS seed collection and preservation program. And he provided blue ash seed from, it was at least a couple dozen, more than 20 different populations, more or less across the range, the native range of blue ash. And there's a fellow here at MSU that's really good at getting things to germinate and grow. Blue ash is another one that needs at least a year. It's like a, can't remember if it's a warm and then a cold stratification or vice versa, but it was close to 14 months before they germinated. And so the seedlings that did germinate, we put them in a nursery bed and held them for a year, let them get a little bigger and stronger. And then we divided them. And so now we have, I guess you'd call that like a provenance trial almost, where we have these different sources of the different parent material. And we have blue ash planted not far from campus in this kind of mid-Michigan area. And then we took seedlings and planted them up by Escanaba in the UP. MSU has a research forest up there. And we go in every year close to campus here. We measure them, we count them. We've had incredibly good survival, less than a handful. I don't know how many, we have at least 400 or so seedlings. And they're not seedlings anymore. Some of them are taller than I am, and they're, what, 4 years old or so. In the UP, it's not quite that good. I think there are going to be seed sources, parent origins, whatever you want to call it, that don't do well in those cold areas. But I think some of them are going to do just fine. And I know there are some blue ash trees growing in areas north of the Lansing, East Lansing area, maybe 100 miles north, exposed to some pretty severe temperatures there. And those are, it's not very many, but it's a couple of mature trees. So yeah, I think that's a good question. And we're trying to get at that. It just takes time, and you got to have some severe winters to challenge them. And we may end up with at least a few options in terms of blue ash that can survive and are maybe more cold hardy than what we would have expected.
Yeah, we don't have any, I would defer to Deb on it. And I guess one question, I guess, for Deb, knowing what you know about where blue ash exists elsewhere, it seems like maybe more upland settings that it would make sense to deploy that species versus lowlands.
Yeah, if you put blue ash on a cruddy site that, it doesn't take flooding very well, I'm pretty sure. It doesn't take shallow soils very well. If you have nice kind of upland soils, places where almost like northern hardwoody kind of sites, good soil, decent drainage, blue ash will thrive. And I think part of the reason it's not so abundant as it might be is just the difficulty it has in terms of germinating and getting established. So I think there's options for it. My personal feeling is it may be more important as a landscape tree, something to replace ash trees in a lot of the areas where they were used at one time. But it would be really cool to start putting some blue ash. In fact, I've done it. There's a big park system here, and I've worked with the naturalists there, and we've put a half a dozen blue ash into a park. That would have been in about 2012. And they're doing great. They're thriving. They get browsed down a little bit, but they're probably 10 feet tall now. So I think it's possible.
Cool. Well, I think we could do this all day, but I think we better shut her down so people can get back to their regularly scheduled programming. So I'd like to thank you two so much for coming and talking with us. And I hope you guys will be around for some more of these. So,
Yeah.
And I don't know if people will contact you, but both of you are available through email, if that's okay.
Absolutely.
Yes? Okay.
Sure.
So
You
if
can find us online.
All right. Sounds great. And I guess I throw in a little plug for next week if you guys, if people are available. Next week will be at the same time as well as the next 5 weeks. And we will be looking at regulations and planning. So kind of looking at what regulations are out there. We've got the deregulation coming up with APHIS. We got some risk assessment stuff to see, how at risk are your forests, and should you really be putting a huge effort in, or should you be doing some of this chemical treatments or whatnot. Looking at what, for the tribe aspect, what kind of authority does the tribes have? Like, what can they do in the wake of EAB? And then also Lacey will be talking about the pest survey program that WCAG has going on across all 11 tribes, I believe. Might be only 9, but potential. So we've got Herb Bolton, Steve Garsky, Philomena Quebec, and Lacey next week. So please come join us. We'll be at the same place. All right.
All right.
Thanks, everybody.
All good
Thanks a
seeing you.
lot.
Thanks
See
a
you,
lot.
Tony.
Thank you.